Hi, my name is Brian Liu. I am in third period of AP Calc AB, and today I will be teaching you how to do the AP Calculus AB Free Response 2011 Question 1.
This problem gives you a bound region from 0 to 6, and it also gives you the function of velocity and the function of acceleration. Question A is asking, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. Acceleration and velocity are both vector quantities, accounting for both changes in magnitude and direction. Because of this, if both the signs of velocity and acceleration are the same, then speed is increasing. If the signs do not match, then it is decreasing. So by knowing this, we are going to plug 5.5 into the velocity function, which would give us negative 0.453. So the sign of the velocity function would be negative when you plug in 5.5. So now let's plug it into the acceleration function. Which gives us negative 1.359. So because both of these have negative signs, the conclusion is that the speed must be increasing at t equals 5.5 because the signs of velocity and acceleration are both negative. So the equation to define the average velocity of a function on an interval is given by this. If f is integrable on a b, then average one over b minus a times the integral from a to b of f of x dx. Because this is asking for the average velocity, when you plug in the numbers, it will look like this. Now that we know the equation, we can plug it into the calculator. So on a TI-84 plus CE, you want to click Math and 9 because it is the integral, and you do 0, 6. Don't forget to multiply this answer by 1 over 6, as that is a very common mistake. This would give you an answer of 1.949. So the answer to this would be 1.949. So now let's do part C. Part C is asking to find the total distance traveled by the particle from time t equals 0 to t equals 6. So to find distance, you integrate from the regions and you put absolute value of v of t dt. The reason you do the absolute value is because when an object is moving this way, it could also move back but still in there. So the total displacement would be this, but distance would be greater because it also has a negative component to it. That's why you have to include the absolute value in the integral. So the equation to find the answer to this question would be don't forget the absolute value signs, as this is very important. Without it, you'd be finding the total displacement instead of the total distance. Now that you know the equation, you can plug it into your calculator. So on a TI-84, again, you do math 9 from 0 to 6. And for absolute value, you do math number 1 because it says abs, which stands for absolute value, and you type it in. This gives you an answer of 12.573 as the total distance traveled by the particle from time t equals 0 to t equals 6. So now let's do part D. It's saying for 0 to t to 6, the particle changes direction exactly once. Find the position of the particle at that time. So by knowing that the particle changes direction only once, it changes signs only once. Because you know this, when it changes signs, it changes when v of t equals 0. So you're going to set to sign equal to 0. So when you enter it into the graphing part of the calculator, it looks like this. And this is what the graph looks like. So as you can see, from 0 to around 6 over here, it only hits the graph once. And to find a 0, you do second to find the calc, and you type 2 for 0. And you bound it here at 0, and you also bind it at around 6.06, close enough. And you're guessing around here. And which gives you a 0 of 5.196 as your 0. Looking at the graph, it is going from a positive value to a negative value. Because you know this, the distance graph is going to look something like this, with a positive slope going to a negative slope. And it gives you x of 0 equals 2. So you know that when x is 0, y is 2. By knowing this, you can, to find the distance, you take the initial. When x is 0, y is 2. So you put 2 plus the distance traveled from 0 to 5.196. So this is the distance traveled from 0 to 5.196. And you're going to add this to 2 to find the position of the particle at that time. Now that we know the equation, we can plug it into the calculator. So 2 plus math 9, 0 to 5.196 of this would give us an answer of 14.135. So when the particle changes direction, the position is at 14.135. And now that you know this, you're done with the problem. So yay. Some practice problems you could do for this type of problem include the 2003 FRQ question 2, the 2009 FRQ question 6, 2012 FRQ question 6, and the 1999 FRQ question 1, as well as this link, which brings you to a web page with a similar problem. Thank you for watching my video. Have a great day, and I hope my video helped you in some way.